Okay, so chapter 12, the proper use of can scoops, hotel pans, and sheet trays. Um, Basically, in this chapter, we're discussing um, costing items based on uh, the container size, but also with using utensils. Um, there's three tables referenced in this chapter, and those tables um, refer to the can sizes, scoop and disher sizes, and the sizes of and capacities of hotel pans. So um, it's it's really just using those charts to do your conversions. We're still dealing with fluid ounces, cups, um, and it also introduces and talks about milliliters and imperial cups. It gives an explanation of the difference between um, U.S. cups and imperial cups or British cups. So read up on the difference between those. It's just basically a slight size difference or measurement difference between the two. So I'm going to go ahead and open up chapter 12 assignment and go through this with you. Okay, so number one says a number 5 can holds exactly half of the capacity of a number 10 can. So in the restaurant business or in any type of culinary business, you may order um, different products that come in cans. For example, like stewed tomatoes or any type of canned vegetable, um, purees of different vegetables can come in a can. So there may be some different things like condensed milk and that type of stuff that you may buy in a can and use for the restaurant. But depending on what the product is, it's going to come in one of these size cans. So the way that you cost those items that you're purchasing within the can is typically you have a cost for a case of these cans, or you can buy these cans individually. So, um, but all you're doing to figure the cost when you're costing out these food items is dividing the capacity of the can by the cost. So, number one says, I got a little bit off topic there, but number one says a number 5 can holds exactly half the capacity of a number 10 can. So if you go to page 141 in your book, or sorry, it's page 137 in your book. I was on the wrong assignment. Um, and you look at your chart for number 10 and number 5 cans. They're the first two standard US cans listed on this chart. Um, if you do the division here, take a number 10 can, the capacity, which is 104.9 ounces, and divide that by 2, you can see um, that it does not equal the size of a number 5 can. So that one would be false. And you can use your chart to figure that up. Number 2 talks about dishers. If you see that word disher, that's just a different name for what you might recognize as an ice cream scoop. There's different sizes of dishers as well that hold different capacities. Typically, we're using these for portioning out different food items, whether it be mashed potatoes or rice or anything of that nature. So number 2 says a number 4 disher or scoop holds 4 fluid ounces. Again, you're going to refer to your chart. This one, the chart for scoop or disher sizes is on page 138. So look at your number 4 disher size. Look how many ounces it holds. There's your answer for that one. Number 3 is talking about hotel pans. Some of you may be familiar with different pan sizes, some of you may not. But these are basically typical pans that you use to prepare different items in, bake different items, braise items in the oven in, but they all have different capacities as well. So number 3 says a full shallow stainless steel hotel pan holds 6 quarts of food at a non-spill level. So go to your chart on page 139 and look. The very first line is full shallow. It gives you the dimensions. It gives you the brim full capacity in quarts and liters, and it also gives you a non-spill capacity. So look at your non-spill capacity, and there's your answer for number 3. Number 4 is a true false. Full size sheet tray measures 18 by 36 inches. This one is on page 140. So look at your chart. Or sorry, it's actually in the text right there. Standard sheet trays, also called sheet pans, baking pans, bun pans, are of 2 primary sizes. A full sheet tray is 18 by 26 and a half measures 13 by 18. So there's your answer for that one, top of page 140. Number 5, commercial ovens, racks, tables, and refrigerators are designed to hold full-size sheet trays. This one's also on page 140 in that same paragraph. Continue reading on. Number 6. It's our first math problem on this assignment. Says, if a cake recipe makes 1 full sheet tray of cake and costs $9.36, what does 1 portion of cake cost when the cake is cut into pieces measuring 3 by 2 inches? So if y'all had already done this assignment prior to this lecture, it probably got marked wrong because the correct answer was not in there. I think before it stated the correct answer was 6 cents, which is incorrect. So the way that we figure this one out, you can use your chart on page 140, and you can go down, and it has cutting yields. And if you look at the width and length 3 by 2, it's the third one down, and you go over, it says that cutting a full sheet tray into 3 by 2 pieces will yield you a 6-inch piece size, and it'll yield you 78 pieces. So really, all you have to do to figure this one out is divide the $9.36 by 78 pieces. Now, I checked my math when I did this, and I got the same answer twice. So the way that I checked it is I took the size of a full sheet tray, which was 18 by 26, and I multiplied those two those two numbers, 18 by 26. That gave me 468 square inches. And then I multiplied 3 by 2 because that's the size portion we want. And that gave me 6 square inches. So I took that 468 and divided it by 6, and that got me 78, which was the same total number of pieces that the book has for 3 by 2 pieces. So if you wanted to check it, that's how you would check it. But then all you're doing is taking that $9.36 and dividing it by the number of pieces that one full sheet tray of cake would give you, cutting it into 3 by 2s. So that's how you get the cost for that. Did y'all get 12 cents as well?
Yes.
Okay, good.
Yeah, we got hung up on that one.
Yeah, I did too, and I checked it back and forth 2 different ways, and I kept getting 12 cents. So that's what it is. I don't know why it was incorrect in there the first time, but it's not the first time that's happened to us this semester. So
True. Very true.
okay, so number 7 says a recipe for potato salad makes 1 gallon and costs $5.76. How much will a level number 8 scoop cost? So I'm going to do this one on the whiteboard. So let me share my whiteboard with you. Okay, so we're on number 7. So the cost of 1 gallon in this problem is equal to $5.76. Okay. Then the other thing to note is 1 gallon is equal to 128 ounces. Okay. So if you go to page 138 and you go down to dish size number 8 and go over and look to your right, it holds 4 US fluid ounces. So all you do to figure this one out is take your 128 ounces that are in 1 gallon and divide it by 4, which is the size of the scoop, or how many ounces are in the scoop. So that would give you 32, right?
Yes.
Okay. So now all you have to do is divide your cost, $5.76, $5.76 by 32.
Yes.
And that'll give you the cost of 1 scoop. Everybody get the same thing?
Yes.
Yes.
Okay. I'm trying not to give out the answers when I'm doing this anymore.
Nope, understood.
Because I was just giving you the answer, but yet, everybody needs to work it out on their own. But I'm showing you how to get to there, so.
Well, it's being helpful because we're able to actually do it on our own now.
Yeah, so. But this is the same math that we've been doing the whole book, really. It's multiplication and division. Okay, we're just dealing with different portion sizes and things of that nature. So number 8 says a hotel pan containing a casserole costing $18. You get 21 portions from one pan. What does one portion cost? That one is as easy as it gets. Take the cost of $18, divide it by your portions. That gives you your answer.
Yep.
Number 9, if you get all the ingredients out of the number 10 can costing $8.68, what will 1 cup cost? Okay,
Mm-hmm.
so let's go to our chart on page 137 for this one. You can see the total number of fluid ounces in a number 10 can is 104.900. So if you're trying to figure out what 1 cup will cost, first of all, you need to divide. This is number 9, by the way. I'm going to put it on the board. So, a number 10 can is equal to 104.900 ounces. Okay? So, you're trying to figure out the cost of 1 cup. So take your $8.68 and divide it by that 104.900. That will give you the cost of 1 ounce. Okay? Then all you're doing is taking that cost of 1 ounce and multiplying it by how many ounces there are in a cup. We should know that by now, right?
Yes.
8 ounces in a cup. Okay? And that will give you your answer. You should get a long decimal, but
Yes.
it will round to the correct answer.
Okay. Got it.
Okay? We good there?
Mm-hmm.
All right, number 10 says, how do hard plastic hotel pans differ in their holding capacities compared to stainless steel hotel pans? This one's going to be on page 139 in your text at the very bottom of the page.
Chef Pete,
Yes, ma'am?
I have a question on number 9
Okay.
because I did the different way. I used the US cups amount that is shown on the book,
Uh-huh.
and it gave me the same result.
Okay. You use the 13.113?
Yes, sir.
Okay. Yeah, if you do it either way, it will come out.
Okay.
You should get the same answer.
Okay.
Yeah, you can do it either way by the
But
ounces in the can or the cups in the can, either way.
okay. Thank you.
You're welcome. Yeah, but that last one, talking about hotel pans,
Mm-hmm.
like I said, that one's on page 139 at the very bottom of the page. That last little note talks about the larger the pan, the less plastic reduces the pan's capacity compared to stainless. So, okay, that's chapter 12. I'm going to move right on to chapter 13 if y'all don't have any questions.
No, we're ready.
That one's fairly easy compared to what we've been doing. Okay. We're almost there.
Mm-hmm.
Only 2 more chapters after this one. Okay, so chapter 13 is dealing with some measurement conversion. So, we typically use a combination of these different units of measurement in the kitchen. So we may weigh things in ounces and pounds, but we also going to use grams as well. We may measure things in quarts and cups, but we're also going to use milliliters and liters as well. So both U.S. and metric, and it also discusses British imperial. Basically, that goes off of capacity when it's talking about cubic inches, square inches within an item. So there is a little bit difference, and it also mentions a French term called avoir du poids, which basically is translated to goods of weight. So in this system, pounds and ounces are used to measure mass and specify that a pound equals 7,000 grains as divided into 16 ounces. So it uses a different system of measurement in that it uses grains, but grains are equivalent to what we measure in ounces. So, and you can also convert grains to milligrams as well. So, just to give you a heads up on that. So, number one on this assignment for chapter 13 says American and imperial British fluid ounces are equal, both measuring 29.573 ounces. So you need to read about American and imperial systems on page 141 to get this answer. But I can tell you that it's in that paragraph where it's discussing both the U.S. And imperial systems for pounds and ounces and weight. Okay, and then it goes on to discuss fluid ounces and the difference between imperial and American fluid ounces. So read page 141 to get your answer for that one. Number two says a liter is 1/10 of a meter cubed. So on this one, for this one, go to page 142. Metric system is in the middle of the page. Read below that. That discusses liters, and it discusses the equivalence of liters to meters in the middle of that paragraph. So your answer for that one's right there. All right, number three says a liter is a little bit bigger than a quart. You can find this one on your on page 143 on your chart. So if you go down to liters, you can go over to liters and see the equivalent in U.S. measurement. A liter is equal to 1.056 quarts. So there's your answer. Number four. That one's on page 143 on the chart.
Okay.
If you go down to liter and you go over, you can see the equivalence of 1 liter to quarts. Okay. It says 33.8 fluid ounces or 1.056 quarts. Well, we know.
Okay. Because I use the one on the top where it said meter, square meter, and liter. It said liter relates to quarter.
Okay. But if you're talking about how much it measures,
Mm-hmm. I have to use the one in the bottom.
yeah.
Okay.
All right. Number
4.
4. Imperial pints, quarts, and gallons are nearly 20% larger than their American counterparts. This one you will find on page 142 in the middle. Nearly. Where did I find this one? Okay. If you're looking,
Consequently.
yeah, consequently, right there, where it's that paragraph that starts with thus the U.S. fluid ounces is 1.22 grams. If you continue reading right there, it says gallons are about 20% larger than their U.S. pint. Okay.
Okay. Thank you.
Number 5, quarts and gallons are measurements of space, not weight. Number 5 is also on page 142 at the top. It's actually in that little note at the top where it talks about volume measurements such as gallons are defined by volume standards. This means a gallon is determined by its cubic inches, not its stated weight. So volume is a measurement of how much space an item occupies. So there you go. Number 6, ask how many cubic centimeters equal 1 liter. This one's also on page 142. Under metric system, where it says a liter is defined as 1/10 of a meter cubed. Picture a square box, a cube that is about 4 inches long on all sides. 1/10 of a meter equals 10 centimeters. So then it shows you how to determine multiplying 10 centimeters by 10 centimeters by 10 centimeters gives you 1,000 cubic centimeters. So it explains that right there. Number 7 is that term I mentioned earlier. I don't even know if that I'm saying it correctly, but avoirdupois is a French term meaning. This one will be on page 141 under American and Imperial systems. And I think I even said the answer earlier for that one.
Mm-hmm.
Okay, number 8. 160 degrees Fahrenheit equals what temperature Celsius? This one is on page 145. There is a little chart there on temperature. So read that about the Fahrenheit system and measuring temperature in Celsius centigrade system as well. You'll find your answer there. It also tells you how to convert from Celsius to Fahrenheit as well. Number 9, how many centimeters equal 1 inch? That one's also on page 145 under length. It gives you some standard conversions there of miles to yards to meters, meters to inches to feet, yards to inches to feet. So you'll find your answer for how many centimeters are in 1 inch there. And then the last one for this chapter is how many liters equal 3 US quarts. Okay, so if you need to, you can use your chart in your book for this one, but I just went off of what the information I already knew. I know that there's 32 ounces in 1 quart. So the way that I did this one, it's asking how many liters are in 3 U.S. quarts. So if there's 32 ounces in 1 quart, I multiplied that by 3. Figure out how many ounces are in 3 quarts. So that gave me 96 ounces. That is the equivalent of 3 quarts, right?
Yes.
96 ounces is equal to 3 U.S. Okay. Then, if I look at the equivalent of ounces in a liter, there's 33.8 fluid ounces in a liter. So all I'm doing to determine how many liters equal the 3 quarts is dividing that 96 ounces by 33.8, which is how many ounces there are in a liter. And that should give you your answer. Everybody get the same thing?
Yes. Well,
Okay.
I think.
There's probably another way you can do this as well. As a matter of fact, I know there's another way you can do it. Because it also gives you the equivalent in liters. Well, a liter is a little over 1 quart, 1.056. So you really need to figure out how many ounces are in 3 quarts to determine how many liters are in that amount of ounces. So that's the easiest way. 96 ounces in 3 quarts, divide that by how many ounces there are in 1 liter. And that gives you the amount of liters equal to it. Any questions here?
Not here, but on chapter 10, 11, and 9 to 11 test. 3 questions.
Okay.
Okay, on chapter 10, question number 11.
Hang on a second and let me pull it up.
Mm-hmm.
Okay, full grades. Assignment number 10, you said?
Yes, sir.
Okay.
Question number 11.
Okay, question number 11.
Okay, on that one, when we did the assignment, on that question, they only marked one good and the other one wrong.
I see
And
that now that I've got yours pulled up. Yours is correct. You've got the correct answer in there. 2.48
and 20. Uh-huh.
and 20. That's correct.
Okay, because it marked me one wrong.
Okay, I'll correct it.
Okay. The other one
it marked it wrong because the answer that it gave, it rounded it to 2.5.
Okay.
That's the only
Okay.
reason it marked it wrong. So I'll give you credit for that.
So the correct
Okay.
one is 2.5.
Well, 2.48 is, if you round it, it's equal to 2.5. So that's why I will accept that.
Okay.
Your answer is fine.
Okay.
And
Thank you.
then you said chapter 9 through 11
No,
test, or
chapter
11.
11. Mm-hmm.
Okay. 11 assignment. Which number on this one?
On chapter 11, question number 3.
Number 3.
Uh-huh.
Combined breast, wings, thighs, and drumsticks weigh approximately 68% of the whole bird's weight.
Okay, but when we read in the book, it's at 67.9.
Yeah.
And we marked that one false.
Well, it says approximately.
Mm-hmm.
That's the key word there.
Okay,
So
so we should mark.
Technically that one's true. It's kind of a tricky question. I
Mm-hmm.
see. Because it's not, I mean, it's not 68%, but it's close
But it's
to it.
almost. Mm-hmm.
Yeah.
Okay.
I see that's on page 125
Mm-hmm.
of your book. I'll give you
Yes.
credit for that one. I'll give you credit
Okay.
for that one.
And now
I'm not a fan of that question. And then now the chapter 9 through 11 exam.
Yes, sir.
On which one on this one?
Okay, this one is question number 22.
Okay.
Because on the first
Number
test,
20,
number
number
22.
22. Or okay.
22.
You've got number 22 correct.
No, it's on the test.
Oh, okay.
On
On
the
the 9 through 11 test?
Yes, sir.
Okay.
I did not submit that one yet
Okay.
because on the question number 22,
Yeah.
on the first test, you told us that the answer was 39.77, and that answer is not on that question.
I saw that too when I submitted
Let me
mine.
go. All right, let me go back to my notes for chapter 11.
That's chapter 11?
An oven.
No, that's chapter 9, I think.
Chapter 9.
Mhm.
Okay. Let me go back to chapter 9. Well, all you're doing there is dividing 12 by 14. Right? Yeah, and then
Let me-
moving your decimal place over.
Okay, but when we did the assignment with you,
Uh-huh.
you told us that the real answer is 39.77, and then you fixed the 1.16 to 39.77.
Are we talking about the same problem?
The number 22, hold on, let me try to find it on the
An
chat.
oven ready roast weighs 14 pounds. After cooking and resting, it weighs 12 pounds.
Mm-hmm.
What is the cooking yield percentage?
Yes, let me find where is
There's
that
only
one.
one way to do that. And that's
Okay,
divide 12 into 14.
and it's 85.7.
That's correct.
Okay.
I don't know how unless I was mistaken earlier,